Before we get started for the lesson today, you're going to need your white note packet open to page 15 is where we are going to start. You will also need this class copy of the factors list. It is on your tables and it is cherry or red. Please have this in front of you for the lesson. Take one now and put it by you so you have it for the lesson. Please make sure with this cherry piece of paper you do not write on it. Put it back in the bin at the end of class so that it can be used by all students today. Do not write on the cherry piece of paper. It is for a reference only. Let's start our lesson. On page 15 in your white note packet, your essential question for today says, how can I represent whole numbers with rectangular arrays to determine if the numbers are prime, composite, odd, or even? All of these vocabulary words you have heard in elementary school, and today we are going to talk about them. Prime, composite, odd, and even. Let's take a look at question number 1 for the day. It says, Jenny, Anne, and Gigi have different numbers of pennies. We've been talking about pennies with rectangular arrays since the beginning of this week. Each girl has between 10 and 40 pennies. Let's look at the question in the margin for part A. It says Jenny can arrange all of her pennies into a rectangular array that looks like a square. Looking like a square means it has the same number of rows as it does columns. All right, it's time to grab your cherry sheet of paper and let's take a look. Again, remember, do not write on this sheet of paper. We are going to start looking with the number 10 because they have the numbers 10 through 40. I'm going to write on my piece of paper. You cannot write on yours. The number 10 does not have any squares. 1 by 10, that's not a square. That would look like in your warm-up today when you had 1 by 10. 2 by 5 is not a square, that's a rectangle. So if you were to have 2 by 5, that is a rectangle. So 10 will not work. If we look through our cherry piece of paper, 11 will not work. 12 will not work. 13, 14, 15 will not work. 16 will work. Do you notice that 16 has 4 by 4? 4 times 4 is a square. Therefore, 16 can be one of the numbers. On your note sheet, please circle the number 16. Let's go back to the cherry piece of paper. 17 will not work. 18 does not have a square. 19 will not work. 20 does not work. 21, 22, 23, 24 do not work. 25 will work. 5 times 5 is 25. So on our note sheet of paper, we're going to circle the number 25. Do you notice that 4 times 4 was 16? Please put this on your notes right now. And 5 times 5 is equal to 25. If we continue looking at that cherry piece of paper, the next number that is going to work is 36, because 6 times 6 is 36. So according to these rules, Jenny could only have the numbers 16, 25, or 36. Those are the only numbers that make the square. Let's take a look at part B. Anna can arrange all of her pennies into 5 different rectangular arrays, which means there are 5 ways to get to her number. Let's take a look at our cherry sheet of paper. Again, we're starting at the number 10. Do not write on this sheet. We need to find a number that gets 5 different ways or 5 factor sets. 10 does not work. When we're looking at this one way and 2 ways. 10 only has 2 ways to get to that number. If we continue to look through this cherry sheet of paper, the only number that you can get to 5 separate ways is going to be the number 36. Again, make sure you're not writing on this paper, but just noticing. 36 has 1, 2, 3, 4, 5 different ways to get to it. So we are going to go back to our note sheet and say that the only number Anna can have is the number 36. Let's take a look at Gigi's rules. It says whenever Gigi arranges her pennies into a rectangular array with more than one row or column, she has a remainder. So that means we are looking for numbers that can only make one rectangle. It cannot make a second rectangular array. Again, let's look at that cherry sheet. Starting at the number 10. As we said before, the number 10, we can make it 2 separate ways, 1 times 10 or 2 times 5. The number 11, however, we can only make one rectangular array. We can only set it up as 1 times 11. There is no other way to get to 11. So 11 could be one of Gigi's numbers. Let's go ahead and circle it. As we continue to look at that cherry sheet, make sure it's out in front of you. Notice that 12 has 3 separate ways to get to it. 1 times 12, 2 times 6, and 3 times 4. 12 would not have a remainder situation. 13, however, we can only get one way. 1 times 13 is the only way. As we continue to look through our cherry sheet of paper, 17 could be one of her numbers. 19 could be one of her numbers because it's only 1 times 19. And then continuing on, she could have 23. She could have 29. She could have 31. And she could have 37. So Gigi could have the numbers 11, 13, 17, 19, 23, 29, 31, or 37, based on her given rules. Let's go ahead and flip our note sheet to page 16. On page 16, it says identify prime and composite numbers. You may have heard of these words before. If we read in the margin, it says a number can be arranged into 2 or more than one rectangular array, such as Anna in part B of the problem. It's called the composite numbers. List all of the composite numbers less than 15. So again, take a look at your cherry sheet. Now we are dealing with the numbers 1 through 15, and we need to find all of the numbers that have more than one rectangular array. So looking at that cherry sheet, 1 is not going to work, and 2 is not going to work. 3 also will not work because there's only one way to get to those numbers. 4, however, is a composite number because there are 2 different rectangular arrays we could make, 1 times 4 or 2 times 2. Because of that, on our note sheet, we're going to go ahead and circle the number 4. If we continue to look at that cherry sheet, 5 only has one rectangular array, 1 times 5. 6 has more than one. 7 only has one. 8 has more than one. 9 has more than one. Be careful with thinking about if it's only even, odd numbers as well, because 9, look at your cherry sheet, is 1 times 9 and 3 times 3. It has more than one rectangular array. So does 10. 11 only has one. 12, 14, and 15. The composite numbers that are less than 15 are 4, 6, 8, 9, 10, 12, 14, and 15. They all have more than one way to get there. Part B says consider the number 17, which could be Gigi's number. 17 pennies can be arranged into one rectangular array, 1 penny by 17. Any number like 17 that can form only one rectangular array is called a prime number. Find all of the prime numbers under 25. Again, you're looking at that cherry sheet of paper. Number 1 is actually not going to be a prime number. It's not going to be a prime number because 1 and 1 are the same number, so that technically is not going to work. 2, however, will be a prime number. We can go 1 by 2. So when we go ahead and look at this, 2 is a number we're going to circle. It's prime. The only way to get there is 1 times 2. 3 is a prime number. The only way to get there is 1 times 3. 4 is not. 5 is. Again, you can look at your cherry sheet to make these choices. 6 has 2 different rectangular arrays. 7 only has 1. As we continue looking through this list, 11 has 1. 13 only has 1. 17 only has 1. 19 only has 1. And 23 only has 1. These are your prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, whoops, made a mistake, it's okay, I'll fix it, 17, 19, and 23. Closure. All odd numbers are prime. Well, let's take a look at our problem above. All odd numbers are prime. If that is a true statement, that means we would have circled all of the odd numbers. 3, 5, and 7 fall into that category. 9 does not. 15 does not. 21 does not. And 25 does not. They are odd numbers, but they are not prime. So the answer to our closure is going to be are not. And the proof for that. An example for this is going to be the number 9. Our proof would be the fact that 9 is 1 times 9, and it's also 3 times 3. Because it has more than one factor pair, it is not prime, but it is odd. At this point in time, you need to make sure that you put your cherry sheet away. Do not take it with you. Then put your notes away and start your homework for tonight.